Hi, my name is Khalil. I like programming applications, whether it is web or mobile applications, and I also really like working on projects related to the Internet of Things for agriculture. I have already done some projects related to the Internet of Things. I made a system that contained a network of connected sensors. I tried to make a connected solar tracker. I made a connected water filtration and automatic watering system. I made a house model during my participation in the 2019 Solar Decathlon Africa competition. I made a smart connected plant pot with some connected sensors, and I made an Internet of Things mobile application. So all of these projects involve electronic skills and especially programming skills, because I could never make these projects without having programmed the electronic components and without having also prepared the application that will allow me to organize and process the data collected remotely and then display them on a web or mobile interface. So the subject of my project is designing and programming an online buying and selling website of farming stuff, and can also implement a connected hydroponic system. The idea is simple. We have a plant, it's put into a connected hydroponic watering system. This system will take care of the plant, and at the same time, this system will capture data to send them directly to a web application in real time. That's all. So this is the main task of the project. And in order to make things more interesting, I thought of putting this project in the form of a web application for online purchases of supplies and accessories for the implementation of a connected hydroponic system. So the user will be able to order this system, pay for it, put it at home, and follow online the state of his plants in real time through his personal account. So the fact of making this project seems to be easy to do for some people, but to tell the truth, this project is so difficult to make because it includes 4 different areas. The first area of the project is computer programming. That means developing the backend and front-end part of the web application. So to develop the backend or front-end part properly, there are some necessary technologies that must be used. In the backend part of the project, I use Spring Boot. Spring Boot is a framework that provides tools to make the development of an application more easy. Thanks to Spring Boot, I was able to divide my project into small applications called microservices. A microservice is a part of the project that can be developed separately by a team member with his own language and his own way, while other microservices can be developed by other developers with different programming languages, and so they can communicate with each other without any problem. And all of this thanks to Spring Boot. So Spring Boot also allowed me to secure my project to protect my data from external attacks. To develop the backend part, I used Eclipse Photon. It is the same programming tool used by the backend developer. I made all the microservices of my project. They can communicate data with each other, and this data is stored by 2 types of database management systems, MongoDB and MySQL. In the front end of the project, I use Angular version number 8. It is an open source framework that allows the creation of the interfaces of a web application. I use version 8. It is the same version used by the UI developer To develop the front-end part, I use Visual Code Studio, and there is some components I prepared to build my application well. And for a good way of working, I adopted the DevOps methodology by working with Jenkins, Git, GitHub, Docker Hub, and Kubernetes. The second area of my academic project is Internet of Things for Agriculture. In this case, the first connected thing is a plant. It is watered with the hydroponic technique, and at the same time, the plant is surrounded by a number of sensors and other electronic components. The plant communicates some data with the second connected thing, which is a microcomputer associated with a camera, and this microcomputer will send the data received directly to the web application so they can be clearly visible to the user. Now the third area of my project is 3D design. Like I said before, in my project there is a plant inside a hydroponic connected system, which means there will be a model in the form of a pot in which we will put the plant, and it will be connected and at the same time watered with the hydroponic technique. So to produce such a model, it is necessary to use the 3D drawing of this model. To achieve this, I use SolidWorks. The fourth and final area of my project is big data. Here is again the schematic of my project. As you can see here, there is a microcomputer specifically there to send data immediately to the web application. In fact, the microcomputer does this in real time again and again, and things become more complicated when you have to receive and manage thousands of data per second at the same time and quickly. This is what we call big data. And to solve this kind of problem, we have to think about using Kafka Stream. Kafka Stream is a streaming platform that provides us with a number of very useful features that allow us to manage a large amount of data in real time and continuously. So this is why I use Kafka Stream in my project. Now let's take a look at the web application. As you can see here, on the first page of the application there are several buttons to click in, and each button represents a specific functionality. So if we want to run our application, we must first start our two database management system, MySQL and MongoDB. Now I'm going to start MySQL, and it's done. Now I'm going to start MongoDB, and it's done. Now we start the backend part by opening Eclipse, and then we start all these microservices here. As you can see, the application is divided into different microservices. Then we start the front end part here with the command ngserve. And here is the application is working now. As you can see here, there is the home button to go directly to the main page, the search bar to look for a product, the login button is to go to the authentication page, help is to access the different information related to the website, the virtual basket is to access the different products that have been chosen to buy them. Here we display today's climate forecast. Here are the products and services offered for purchase. Here is to buy a connected hydroponic system. Here is to benefit from the maintenance service in case of problem. Here is to buy the different seeds to plant. And here is to buy the necessary accessories and equipment to set up a good connected hydroponic system, and that's it. Let's assume that the user has already registered and he would like to access to his account. To do that, he must click the login button. He fill in the following fields. He click here, and that's it. Now the user is registered. After that, the user will be able to think about buying some product. Seeds, for example. Now I'm going to order some seeds. Here you can notice that there is a notification, which means that the virtual basket begins to be filled with the chosen product. Okay. Now the user will be able to think about buying some accessories. Okay. And now, finally, the user will be able to think about buying a connected hydroponic system. Here there are two types. As you can see there are the fixed type and the mobile type. And it is the mobile type that interests us the most. Now I'm going to talk about something else for a moment, because I would like to explain how I came up with this mobile hydroponic connected system. To do so, I first spent a whole week preparing the 3D version of the model using SolidWorks software. So this is the model of the system. We put the plant inside. There is a cover here. We can remove it as well as we can put it back on. Once I finished my 3D model, I used hydroponic software to prepare all the parts of the model in 2 dimensions. Once it was done, I put the parts in my USB key and I went to look for a laser cutter. Laser cutter is a machine capable of cutting and engraving material using laser. This machine is capable to cut and engrave wood, fabric, paper, plexiglass, or even iron. So the material with which I decided to produce my system is plexiglass. As you can see, this is the plexiglass. Now that I have the material, what I have to do now is to go and get the laser cutting machine. So I went to Fab Lab Casablanca. It is a place open to the public, and it provides all the accessories and tools for the design, the manufacture, and the realization of a product. So here is the laser cutting machine. It is cutting out the pieces of my model, as you can see. Here are the pieces well cut out. Here is the assembly. Here is the whole system well assembled. I took my time to color it with the teal color. We can put in 2 plants like we can put in 1 plant. If we try to see the inside, we can find the water part and also the electrical part. So here is the electrical circuit of this electrical part. First, there is the microcontroller node MCU. If you want to power this microcontroller with a 220 volt, we are going to need an adapter to reduce the 220 volts into 19 volts. Then we are going to need also a step down to reduce the 19 volt to 6 volt. Now the node MCU works fine. It can control the other electronic stuff. It can control the water pump to water the plant. It can control the DHT22 sensor to know the actual temperature and humidity of the place. It can control the fan to cool off the place in case of heat. It can control the LED light bar to generate artificial light for the plant. It can control the sensor LDR to know if we are in a sunny place or not. The microcontroller gonna need two relays to control water pump and the LED light bar. So there is also a microcomputer Raspberry Pi 3. It is powered by power bank. This microcomputer is acting as a server that do some different development work and can also record a video using the camera Pi. So this is the electrical circuit of the hydroponic connected system. So what makes the system connected is thanks to these two components, Node MCU and Raspberry Pi 3. Node MCU captures the current temperature around the plant. It sends the data to Raspberry Pi, and then Raspberry Pi receives the data and at the same time record the current video of the plant and sends all the data to the website. Let's go back to the system. Here is the temperature and humidity sensor. Here is the fan to cool off the place in case of heat. Here is the Node MCU. Here is the patch of the water. It's going up here and then come back again. And here is the box that contains the microcomputer Raspberry Pi with the camera. Now let's simulate the system by trying the artificial light. To do that, there is a light sensor up there, and I'm going to put my hand on it to make the system believe that this is night. Now I'm going to take off my hand to make it believe that this is day, night, and day. Now let's simulate the watering system. As you can see, the water is going from here, then up, then go back again. This is what we call the hydroponic technique. Now I'm going back to the web application because I stopped for a moment to talk about how I made my hydroponic connected system. I'm going to order the system. Now we see the contents of the virtual basket. Here are the products that are ordered so far. I can increase the number of the same product if I want. As you can see, the price automatically change. Make the purchase. I fill in the necessary fields. And then I click here. And here I am done with my order. Now if I would like to know the list of products that I have bought so far, I can access here. Now about the connected hydroponic system, I install it in a safe place and it works. Now I can access to the next page and I can follow in real time and continuously the current state of my plant. As you can see, here is the value of temperature and humidity in real time. Here is the diagram that represents the values of temperature and humidity over time after each second. And here is the streaming camera of my plant. To make this part of Internet of Things work, we should start the program of C language in Node MCU, because Node MCU is the microcontroller that gets the values from sensors, then send them to the microcomputer, the Raspberry Pi. We should also start the Java program on Raspberry Pi, because Raspberry Pi receives the data from Node MCU, then at the same time, Raspberry Pi starts doing some management of data using Kafka Stream, then immediately send all the data including video recording to the local server, then the local server displays the results on website. So that's it. This is the application. And to be capable of making this application in good professional conditions, I follow the DevOps approach by using the following tools. There is Git. This is the software that allows us to send our application directly to GitHub. Once it is sent, we can add, modify, or delete with the same software. There is also GitHub. This is the website where we can put our application so it can be easily accessible by all team members. There is also Jenkins. It is the software that allows us to take the application source code from GitHub, compile it, create our Docker image, and then publish it in a Docker Hub container. There is also Docker Hub. This is the place where the Docker images are hosted in virtual containers so they can be easily accessible by all team members. And finally, there is Kubernetes. This is the open source system that automates deployment of an application. Thanks to Kubernetes, where we take the Docker image already stored in Docker Hub and deploy it easily. Now this is how I use the software Git to send my application to GitHub. As you can see, the application was successfully put in GitHub. This is the software Jenkins. I am using it to take the application source code from GitHub, then compile it, then create the Docker image, and then publish it in a Docker Hub container. This is Docker Hub, and as you can see, the Docker image was successfully stored in Docker Hub. And finally, this is Kubernetes. I'm using it to deploy the Docker image that I took it from Docker Hub. And as you can see, this is just the front end of the application successfully deployed virtually. So that's it. That was my presentation. I hope that you have assimilated my explanations. I want to remind you that I am Khalil. I am passionate about computer development, whether front end using Angular or back end using Java. I have already done many projects related to the Internet of Things, and thank you for your attention.